Happy Thursday, everyone. Again, as I told you guys yesterday, that Monday I wouldn't be here today as well. So we had a little review. I gave you guys the review sheet yesterday. If you weren't here yesterday, there are stacks on my desk, and I'm sure Miss Bowles would be happy to share with you. So this first group of problems want you to just simply rewrite in radical form. So we're going to do that. Remember the deal. These are rational exponents, or what we say fractional exponents. Fractional means rational. Rational can always be rewritten as a radical, and the key is the root. Remember, the denominator of that fractional exponent is your root. So I could rewrite this as the fourth root of 16, technically to the first, but you don't need that to the first. So there it is, fourth root of 16. Okay, this one, again, what's the denominator? 3. So it's cube root of, and then, of course, a squared. Very simple stuff. This one, you've got the fifth root of, and then, again, this whole thing is in parentheses, so it all needs to be raised to the second power. Now, if you'd like at that point to rewrite that, feel free. And you can rewrite that to the fifth root of, remember the root stays the same, but I might square the 2. 2 squared is 4, and then y squared. So if you want to rewrite it like that, that would be the simplified value. So honestly, either one of these two prove that you know what you're doing. So I would accept either one. All right, now go the opposite direction. Now we want to rewrite these in exponential form. So again, when I see this cube root and they want me to go as an exponent, I know that a radical can always be rewritten as a fractional exponent. And remember, the key is the root. The root is 3. That's my denominator. And then, of course, the radicand, the value inside is the base. And if it's being raised to an exponent, that goes in your numerator. If not, you put a 1 up there. So 17 to the 1/3 power. All right, number 5. We very similar to number 3, but just reverse. You see the radical, so you know it's a fractional exponent. That root is the denominator. Then we have all of 7x that's being raised to this power where the exponent is 3. So it's 7x in parentheses raised to the 3/4. Okay? And then this one is a little different than that because only the a is being raised to the 9th power. So again, I recognize that it is in fact a radical. This is understood to be a square root, so I know my denominator is 2. But I'm going to separate these because, see, the 12 is actually not being raised to the 9th power. 12 is technically only being raised to the 1st power. So I'm going to do 12 to the 1/2, but a is to the 9/2. So I'm going to separate those. Where I didn't on number 5, I'm going to do that on number 6 because they're not both being raised to the same power. I hope that makes sense. All right, so very simple stuff. Hopefully you guys are able to knock that out, no problem. The next group, they want you to simplify the expression, and they want us to give the answer in the simplest radical form. So first thing we got to do is we got to utilize the different properties that we know about exponents. For example, in this problem, we're multiplying, and these bases here are the same. Well, when we're multiplying and our bases are the same, we're supposed to add our exponents. Well, if you go to your calculator and you type in, let me reset this before I get started on that. If I add these, I would encourage you guys to use alpha y equals number 1. Let it work with fractions for you. That's 1/8. And then scroll up here and do plus alpha y equals number 1, 5/8. And the beauty of using this is not only will it add it, it'll simplify it. So this ends up being x to the 3/4. but it asks you to write it in simplest radical form. So we're going to take this fractional exponent and we're going to adjust it. So this is going to be the fourth root of x to the third. Now think about it. Is this in simplest form? Well, will 4 go into 3? No. Then x can't escape. It all stays trapped inside. This is my answer. Okay? Now, number 8, what I would encourage you guys to think about on this problem is that in the denominator, this denominator has technically an exponent of 1, k to the first. So I would go to my calculator and I would do alpha y equals 13 over 3, and then I would subtract 1. It'll do all the work. It'll change that to a fraction. It'll simplify it all. You get 10 thirds. So this, because we divided, we subtracted our exponents, and we got k to the 10 thirds power. So there it is. I can't break down 10 thirds, so I'm going to go ahead and rewrite this as a radical. So that is, remember, the denominator is your root, so that's the cube root of k to the 10th. Now, is this one in simplest radical form? No, because 3 will go into 10. It'll go in there 3 times. So since 3 groups of 3 k's come out, k comes out as k cubed. But again, like I just said, that's 3 groups of 3. So 3 times 3 is 9. Only 9 of these k's actually escaped. Well, there was 10. So if 9 escaped, then 1 remained. So it's k cubed times the cube root of k. All right, and number 9. Number 9 is a tricky one. I'm not going to put one of these on the quiz because I'm afraid that you might not understand it. I'm not here to explain it, but a lot of you guys might look at this problem and be like, well, there's no perfect fourth that goes into 100. And I don't disagree. I agree very much. There is no perfect square or perfect fourth that goes into 100. However, 100 itself can be rewritten. 100 can be rewritten as 10 squared. Now, why might that help me? Because I can now rewrite that as a fractional exponent. Remember, your root becomes your denominator. So this ends up being 10 to the 2/4. Well, why does that help me? Well, 2/4 can reduce. It reduces to 1/2, which actually changes the fractional exponent. It changes the denominator. So instead of this being 4th root now, it's square root of 10, technically to the first power. So you're able to break down the 4th root of 100 like this. It becomes the square root of 10. So very different answer, and that is the correct answer. Okay? Now remember yesterday I told you to mark out 10, 11, 12, and 13. We did not do simplify or equivalent expressions, so we're going to hold off on that until we get back from Thanksgiving break. Now, the next grouping has to do with solving radical equations. So let's start with number 14. Remember, the first thing we're going to do is isolate that radical. So I'm going to subtract 4. That's going to leave me with the square root of 5x minus 1. And then 11 minus 4 is 7. So we've done that. We've done step 1. Everything is moved away from this radical. So step 2, when we learned this, was you raise the root. You raise the root, meaning if that's a square root, we're going to raise both sides to that second power. On the left side, the square root and the square cancel, so 5x minus 1 just gets to drop. But on the right side, 7 squared is 49. Then I'm just going to solve a simple problem. Add 1, divide by 5. So x equals 10. Now, unfortunately, because of the nature of these problems, we're then going to go back and we're going to just quickly type into our calculator the square root of 5 times x, which is 10 now, minus 1, and then plus 4 on the outside. And we're going to check to see if that equals 11. Well, 5 times 10 is 50. 50 minus 1 is 49. Square root of 49 is 7. 7 plus 4 is absolutely 11. So since 11 does equal 11, this is my answer. It is not extraneous. Okay? So real quick check. You don't have to spend a lot of time on that. It's just straight in your calculator. Number 15. Again, remember, this is the radical that we're trying to isolate. So the first thing I need to move is this 1 out here. A lot of people may not see that, but that's what's got to go first. So we're going to subtract 1, negative 2 times the square root of m plus 12 equals 4. Now, I still don't have this radical completely isolated. I need to move that negative 2 away from it. Well, remember, when it's jammed right in front of it, it means it's multiplying. So you're going to divide by negative 2. So the square root of m plus 12 will equal 4 divided by negative 2 is negative 2. Now we're going to solve this, and again, we do so by raising both sides to the power of the root. So we're going to square both sides. On the left, m plus 12 pops out, and negative 2 times negative 2 is positive 4. So my last step is to simply subtract 12, and 4 minus 12 is negative 8. Now go grab your calculator and type in there 1 minus 2 times the square root of negative 8 plus 12. And we're going to see if it does, in fact, equal 5. Well, inside here, you've got negative 8 plus 12. That right there is 4. Square root of 4 is 2. 2 times 2 is 4. 1 minus 4 is negative 3. And that definitely does not equal 5. So this is what we call extraneous. We did everything right, but it just doesn't work. It's extraneous. Okay? All right, moving along to number 16. I don't care that this is written as a fractional exponent and you leave it this way. I don't care if you choose to say, hey, that denominator is 3, so I'm going to change this to the cube root of 9a plus 45, and then that equals 3. It doesn't matter, okay? It's your call. Either way, whether I'm looking at this problem with that root of 3 or I'm looking at this problem with that root of 3, I still have to raise both sides to that third root in order for me to solve it. So you're going to end up at this point, because remember, when I have a power to a power, I multiply. And 1/3 times 3 is 1. They cancel each other. So just like the one on the right, 9a plus 45 is just going to pop out of there. Now, on the right side, 3 cubed is 27. So I'm going to solve this problem from here. I'm going to subtract 45. 27 minus 45. Whoops, I don't know what happened. I left my a off. 27 minus 45 is negative 18. And then I'm going to divide by 9, and a equals negative 2. Now, go back, and you can go back to, either equation. I don't care which one you go back to. You can go back to this one right here with the fraction. You can go back to this one right here with the radical that we changed it to, but go check it. So I would open up a parenthesis. Let me do it differently. I would open parenthesis and go 9 times negative 2 plus 45, and I would raise that to the 1/3 power. So 9 times negative 2 is negative 18. 45 minus 18 is 27. The cube root of 27 is, in fact, 3. This works, and therefore this is a solution. It is not a extraneous solution. All right, hope that makes sense. Let's keep on cruising along here. This one has radicals on both sides, but there's nothing else. So we're ready to go ahead and get rid of that by raising both to the power of the root. Well, square root. So we're going to square both sides. So 3n minus 27 comes out, and 43 minus 2n comes out. Now, when it comes to getting these two terms right here that have n's together, I like to move the small one. Is 3n smaller or is negative 2n smaller? Well, negative 2n. So I'm going to add 2n. So 5n minus 27 equals 43. So the next thing I'm going to do is add 27. 43 plus 27 is 70. Last, we're going to divide by 5, and n equals 14. Now again, every time we've been checking our work, and this is not going to change. We're going to still do the same. So I go back to the originals. On the left side, I type in the square root of 3 times 14 minus 27. Now I don't have that written on my paper, so let me go type it in real quick with you. We're going to go square root of 3 times 14 minus 27. So I get 3.87, let's say. Again, it doesn't matter what I get. What matters is when I do the other side. When I do the square root, let me go write it first. When I go do the square root of 43 minus 2 times 14, it needs to give me that same answer. So let's see if it does. The square root of 43 minus 2 times 14, and it gives me, sure enough, the exact same answer. Therefore, n does in fact equal 14. Okay? So there's number 17. Let's keep on cruising. Number 18. Number 18 is similar to that problem, I guess, maybe a little bit. Well, not quite. I don't have radicals on both sides. Of course, some people probably look at this problem and like, you don't have radicals at all. Yes, I do. Remember, this is a fractional exponent. So the root is the denominator. So since I can't really simplify anything here, I'm going to raise both sides to the power of the root. So I square them. So on the left side, I'm left with 18 plus 7k. On the right, I'm left with k squared. So I'm going to load up one side. Well, the k squared is positive over here on the right, so let's bring everything over here. So k squared. How would I move that positive 7k? Minus 7k, and then I would subtract the 18 as well. So I can't just solve for k. I can't just go like, all right, well, subtract or add 18. No, I've got a k squared and a k, so therefore I've got to solve by factoring. So hopefully you guys remember the rules on this. Whenever I am factoring, start with what multiplies to get k squared, k times k. Then we go to what multiplies to get a negative. Well, that's a positive and a negative. So they're working against each other. So we're looking for the two numbers that accomplish this. We're looking for the two numbers that multiply to get 18, but have a difference of 7. Well, that's 9 and 2. It's 9 and 2. It's got to be 9 and 2. So my last step is, hey, negative wins the middle. So if negative wins, it has to go with your bigger factor, 9. 2 here. So if I take those and I set them equal to 0 and I solve, k plus 2 equals 0. I'm going to subtract 2. So k will equal negative 2. And then if I take k minus 9 and set it equal to 0, and I add 9, k will equal positive 9. So let's go check these out real quick. Let's start with negative 2. Now remember, I'm going back up to the original. And I want to check negative 2 first. So I'm going to go to my calculator, and I'm going to type in, open parentheses, 18 plus 7 times negative 2, close that parenthesis, and then I want to raise it to the 1/2 power. So let's go see what that looks like. Open parentheses, 18 plus 7 times negative 2, close parentheses, and then raise that to the 1/2 power. I get 2. Now let's go to the other side. And in the other side, we just type in k, which is negative 2. Guys, does 2 equal negative 2? No, it does not. So this is extraneous. Whoops, I'm going to switch back. Since 2 does not equal negative 2, then negative 2 as a solution is extraneous. Okay, last one, number 9. And again, I'm going to try it right below this. I'm going to type in open parenthesis 18 plus 7 times 9, close both of those parentheses out, and raise it to the 1/2 power. And then we're going to see if that equals k, which is, in this case, 9. So let's go type that one in. Open parentheses 18 plus 7 times 9, close that parenthesis, whoops, and the last one, and raise it to the 1/2 power, and I get 9. So sure enough, 9 does equal 9. That one works, so therefore k equals 9. All right, moving along. Last one, very similar to that one. And so let me go fast. I'm going to square, because that's my root, square root. So if I square both sides, 6x plus 27 will equal x squared. Just like the last problem, I'm going to load up one side. So I'm going to leave x squared alone. I'm going to subtract 6x. I'm going to subtract 27. And I'm going to factor x, positive, negative. Again, I'm doing all these things because at this point, surely you guys have at least a pretty good understanding. So I'm looking for the two numbers that multiply to get 27, but have a difference of 6. Well, that's 9 and 3. That's 9 and 3. So I'm going to put the 9, because negative wins, with the negative, and I'm going to put the 3 right there. So if I take those, set them equal to 0, and solve, I'm going to subtract 3. This one, I'm going to add 9. I don't know why I did that. Got a little ahead of myself. I add 9. So there's the two possible solutions. So let's go through here and let's check them. Again, go back to the original problem, and you're just plugging them in. So I'm going to go to my calculator and do the square root of 6 times negative 3 plus 27. And I'm going to see if it equals x, which is negative 3 in this case. So square root of 6 times negative 3 plus 27. And here I get positive 3. Guys, does positive 3 equal negative 3? No. So this one is extraneous. Okay, last one. Let's try the 9. So I'm going to go square root of 6 times 9 plus 27. And I'm going to check to see if it equals x, or in this case, 9. So here we go. Square root of, should look like the one, above it. Sorry about this. So it should be 6 times 9 this time plus 27. And sure enough, our answer is 9. So because of that, 9 does equal 9, and therefore this one is not extraneous. It's the solution. So there you have it. Real simple. Real simple. All right. Now, I didn't tell you that you needed to get rid of these two problems. I hope that this is not hard for you to do without, graphing it. If you want to graph this, you're welcome to do so. But I'm telling you, you don't need that. You need to simply know where has it moved, okay? And where is it going? So look, this one has moved to negative 2. So that's the furthest it can be on the x-axis. But it's also gone down 5. Okay? So my domain cannot go past -2. Now, it can go to the right forever. So my domain is -2 to infinity. Now, what about range? How do I do range like that? Well, remember, this thing is positive. So at -2, -5, it's opened up like this. So it's going up forever, but it cannot go below -5. It'll go up forever. So sketch it. Make sure you know what it looks like, and that should help you when solving. Now, number 21, we've got negative square root of x minus 3. So the negative thing does play a role, but let's first just remember, where does it go? Well, remember, if that's a -3, that means it actually goes right 3, but it goes up none. But it is upside down, so it's going to do this number because it's a square root function. So what's that mean? Well, for domain it means nothing really. It's going to start at 3 and it's going to go right forever. But range, this thing is going to come down forever. So y is never limited downward. But y is limited up, and that of course is 0. It won't ever go above 0. So you can name the domain range without even having to graph it. Now, I didn't put any transformations on here, and probably could have, and maybe even should have. But anyways, let's go ahead and move along to the last couple of problems where we're going to graph. So, first of all, let's talk about, and I don't know why I didn't write all this stuff out. We could do more than this. We could do the increasing and all this stuff, but here's where I put the transformations. Okay, I'm not gonna worry about on this quiz the increasing, decreasing intervals or the end behavior, but I am gonna ask on this part that you describe the transformations. So maybe you start there. Look, is there anything being multiplied on the outside? No. So this thing is only shifting. Remember how it works? On the inside, that's horizontal, and it's the opposite of what it looks like. So this is a +1 horizontal shift. So this thing is going to shift right 1. I don't know why I'm so zoomed out. It's going to shift right 1. But then on the outside, that's vertical shift. It is what it is. So it's also shifting up 3. Okay? Now, I would encourage you at this point, you know it's going right 1 and it's going up 3. So I would encourage you to go ahead and graph this thing, and then let's check out that it does that. In fact, it's the square root of x minus 1, and then scroll outside of that radical so it stops it and put +3. And sure enough, notice how it goes right 1 up 3. Now, I'm going to go find a couple of nice points. So 1, 3, we got 2, 4. We've got 5. 1, 2, 3, 4, 5. Now let's see if there's any other good ones. There might be one more. Yeah, there it is, 10, 6. I can barely squeeze it on there, but I can. Let's go. So here it is. It starts here. Okay, don't keep doing your graph past that point. That's an end point. That end point is at +1, +3. Now, what's my domain? Well, remember, domain is x. X, is it ever going to be way over here? No, it can't go past this x value right here. Well, what is that x value? 1. It can't go past 1. Now, what can it do to this way? Oh, it can go that way forever. So, infinity. Also with the range, remember, range is y. Well, can it ever come way down here? No. It can come to right here, that's 3, and it will go up forever. Now, very gradually will it go up forever, but it will go up forever. So my range is from 3 to infinity. Okay? And there you have it. Very simple. Last one, it's a cube root function. Cube root functions, they don't have an endpoint. They have a turning point. We talked about this. And you can find it right here. What's that mean? Remember, on the inside, that's horizontal shift, and it's the opposite. So that looks like a +1. It's actually a -1 horizontal shift. So it goes left 1. So shifts left 1. Now, does it ever go up or down? No. So my turning point is at -1, 0. So it should be right here. Let's go look. So hopefully you guys remember, in y equals, to do cube root, we're going to go math, and then there it is. Look, number 4. We're going to do the cube root of x plus 1. When I graph that thing, look, sure enough, it shifted left 1. You can see it. Now let's go find a couple of other nice points. There's -1, 0, which we know to be our turning point, right in the middle. There's a couple of points around it. There's -2, -1, and there's +0, well, +0. There's 0, 1. Let me find another point below it. There's one, -9, -2, and let me find one more above it. And there it is, 7, 2. All right, I got those graphed on my coordinate plane. There it is. That's hopefully what yours looks like too. So this thing is going up from left to right like so. So remember how easy these were? Domain. Does it ever stop going left? Nope. Does it ever stop going right? Nope. So my domain is left to right forever. Negative infinity, positive infinity. Does it ever stop going down? No. Gradually, but yeah, it goes down forever. Up, same. So negative infinity to positive infinity. And that's it, okay? Try not to make it overly difficult. Hopefully you guys will prepare. This video looks like it's going to be about 33 minutes. You need to use this time to study and prepare. Your quiz will be tomorrow. So be prepared, okay? I don't know. I haven't decided if it's going to be a Google form yet or if it's just going to be a piece of paper. I might even do both options. We'll see. We'll see. But be prepared for either one, okay? All right. Have a great day. We'll see you tomorrow.